want to talk about chapter 22. There's a lot of extra stuff in here that we're going to kind of just speed through, but I want to kind of point out what was the most important aspects of chapter 22. First of all, you can see some crazy formulas for standard deviation here because we're going to be combining two standard deviations. And this is kind of coming back from the idea from chapter 16 where you're not allowed to really add variances or standard deviations. You have to add variances. Once you add them together, then you can take their square root again, just like you see here in that second equation down at the bottom. You can then get your new standard deviation by combining different groups together. So no real worry about this. The fact is that you've got two different groups, right? Standard error here is because we don't know P1 and P2 usually. And so these are usually P hats, P1 hat, P2 hat. These means they're estimates. We don't know their actual values. We're using the numbers we get out of the samples. This formula is on your formula sheet, so there's really no need to memorize it or anything like that. This is what we call standard error. And we use this in place of standard deviation because instead of using P1, we're using P hat 1. You can't really see that on the screen here, but these should have hats over them. Okay. Really the biggest difference here in chapter 22 is where we use our significance tests and our confidence intervals. The majority of our material is going to stay exactly the same, which is a good news. Okay. There are a few differences. I want to talk about those today. So let's talk about phantom and panic. Number one, our assumptions and our conditions for these two things are going to change slightly. Randomness, independence, and 10% and success or failure all remain part of the process, except this time where I checked last time for one sample, I'm going to be checking for two samples this time. Randomness, it just means were the samples taken in a random fashion. Sometimes they tell us this, sometimes they don't. And we have to just simply assume, well, if it's not mentioned in the paragraph, I have to assume that it is a random sample unless I have a reason to believe that it is biased. Okay? Independence changes a little bit. We're talking about two types of independence. Number one, are the samples themselves independent, right? When I choose one and I choose the next and choose the next individual item inside that one sample, are those things independent of one another? Two, independent groups. This is a new one. This is one of our newest elements. We're going to have two separate sets of data. And in this case, are those two separate sets, are they independent of one, or did they have an impact? Usually, you'll have a single set of data, and sample 1 and sample 2 both came from the same population. For example, if you're studying a weight loss medication, and you do a before weight, you'd go through the medication, and then afterwards you take another measure of your weight, then you have independent groups fails because your before weight is definitely related to your after weight. And so that is where you have an independent groups situation fail. Right? So when it says independent samples condition, this is two different ones, right? It says the same group of people before and after treatment are not independent, right? That's the real obvious failure here. But there are two different types of independence. Independence just within one sample and then between the two different groups. Then, of course, we have success and failure and 10%. These are the same things as last time, but now instead of checking for one sample, I just have to make sure to check it for both of my samples. Okay. Our standard deviation changes a little bit. Our standard deviation, right? This is a formula sheet. This is on your formula sheet here. This isn't a big deal. I could ask you for this on a test, like what is the standard error for the sampling distribution? And you would have two different samples. You would just plug in the values here and work it out. That is on your formula sheet. Make sure you look that up. Okay. We get two new tools. We get the 2 prop z interval and the 2 prop z test. Okay, the 2 prop z interval, the formula looks like this. What I'd like for you to do, it's P1 minus P2 is the first part. That's the expected difference, right? We would expect to have a difference we'll just subtract the two. Then you're going to have z star times the standard error, which is just this big square root here. So if you'll replace this whole standard error part here with the square root, you're going to be given the actual standard deviation or the 2 prop z interval formula. You're really not going to use this a whole lot because we use the 2 prop z interval in the calculator to do most of our work. Just make sure that you are aware of this. Sometimes you have to work backwards and things like that. So that would be useful just to plug in our values and solve for what's unknown. So essentially it's the same kind of process. It just gets a little bit longer. You're always looking at the differences of the two groups. Okay, so here's an example. You had 1,010 adults. They looked at this and they had two different groups. They had the under 30 group and the over 30 group. Okay, and so here you had 26% of 841, or of 184, and 39.2% of 811, right? And so is there a difference of 13.1%? Is that real? Is it just natural variation? In other words, it's just, if I were to go back and do this again, I could see the differences completely change around, and we would be able to talk about, well, is the difference due to just random chance, or do we think that age actually plays a part, that the older you are, the more likely you are to snore? And so we can kind of do a significance test or a confidence interval and look at this. Okay, so we're going to do the 2 prop z test to work this out. And so you're going to kind of do a couple things. Number one, HO. If you'll notice in your calculator, when you go to 2 prop z test, you don't even get the option for this, right? HO can be written like this, where it has P1 minus P2 equals 0. Or you could write P1 equals P2. In other words, there is no difference between the two groups. That's my assumption to start with, right? You can see it right here, P1 equals P2. For pooling, I want you to really kind of ignore the pooling situation. It is going to automatically happen in your calculator, so we kind of don't really need to worry too much about the pooling part. Our alternative hypothesis, right, is going to end up becoming, let's get to that part. Wow, there's a lot of extra stuff here. Okay, the alternative, let's go back. They're not really going to put it down in the picture, but our alternative here is there a difference? Let's see, what do they say? It just says, is there a difference in the two groups, right? And so what we're going to use, our alternative, is that we're going to use not equal to, because they just ask, is there a difference? They didn't say one more, one less. If they had mentioned it that way, we would have used it that way. In this case, we would get all of our assumptions and conditions. We're going to write those things out. Make sure you're writing the numbers out for these things so that you get justification for they're met or they're not. Right? You have two different age groups here, so independent groups totally passes. Independent samples, one person snoring doesn't affect another person snoring. You've got the randomization part happening, and you got all of this stuff happening, which passes. You're going to get a z-score of 3.33, which is pretty big. You're going to get the name of the test here, remember, is the 2 prop z test. You're going to get a two-sided interval, which is our not equal to, which gives us a p-value of 0.0008, right? So you'd say we reject our null hypothesis in favor of our alternative, and our evidence suggests that there is a difference in snoring rates between the two different age groups. We're always talking about the differences in the age groups when you're doing a 2-sample t-test. That's pretty much it for the 2 prop z interval and 2 prop z test. Okay, it's very similar to previous results. You just got to make sure to check the different assumptions and conditions and all those things like that. If you have any questions, please let me know. We'll do some more examples in the book, and I'll post those so you can kind of see how we get through those as well.